Good afternoon, class.
Good afternoon, Mrs. Food.
You can sit down. All right, then in our previous lesson, we looked at polygons and how to calculate the sum of the interior angles, the sum of the exterior angles, and also the size of an interior angle of a polygon. Okay, note, it's an important note. For any quadrilateral, the sum of the angles is always 360 degrees. The same applies to a pentagon. Even if it is not a regular pentagon, the sum is always 540 degrees. All right, the same applies to all the other types of polygons. The angle sum of the interior angles is always the same. Okay, whether it's regular or irregular. Right, the values of the interior angles will be different depending on whether it is regular or irregular. Like for instance, a regular pentagon has all its interior angles equal to 108 degrees. It's not the same if it is an irregular polygon. They'll all be different, so just take note of that. Okay, we have to look at the homework you were given. Right, question 1, find the sum of the interior angles of a convex polygon with A, 5 sides, B, 8 sides, C, 10 sides, and D, 12 sides. I want some volunteers, please. Okay, Gabriel, the sum of the angles of a 5-sided polygon.
540 degrees.
540 degrees. B, Peter.
1080 degrees.
1080 degrees. C, we.
1440 degrees.
1440 degrees. And D, then.
1,800 degrees.
1,800 degrees. Number 2, if the polygons in question 1, that is a 5-sided figure, an 8-sided figure, a 10-sided figure, or a 12-sided figure, if they are all regular, find the size of one interior angle. Find the size of the interior angle of each. Any volunteers, please? Solomon? The size of an interior angle of a pentagon, a regular pentagon.
Degrees.
Okay, 108 degrees. For an octagon, Daniel?
$135 degrees.
135 degrees. C? Lester?
144 degrees.
144 degrees. And D? Natasha?
150.
150 degrees. Good. Number 3, a hexagon has interior angles of 100, 110, 120, and 128. The remaining 2 angles are equal. You are to find the size of the equal angles. Karanamo.
131 degrees.
131 degrees. Okay, because it is a hexagon, the sum of the interior angles will be 720. So you just add 100, 110, 120, 128 plus those 2 missing angles. You will get 720. So one missing angle is 131. Number 4, each interior angle of a regular polygon is 150 degrees. How many sides does it have? Hekoi.
12 sides.
12 sides. You could have done this without much working out. You could have realized that the the sum of the angles of a 12-sided figure in part 1 is 1,800. And then in part 2, one angle is 150. So all you could have done was divided 1,800 by 150, and you get 12. So, sorry, for number 4, 12 sides. Okay, the last one we are going to do orally now. ABCDE is a regular pentagon and ABX is an equilateral triangle drawn outside the pentagon. You have to calculate angle AEX. Miriam.
Angle AEX is equal to 6 degrees.
Good. Angle AEX is equal to 6 degrees. If this is the pentagon, it is angle ABX is given to be, ABX is an equilateral triangle. So if you draw triangle ABX, this and this and this will be equal. And then AEX would be this angle. This angle is 108 degrees. It's actually quite easy to find. That's an isosceles triangle, which means 108 plus, is it 108? No. This is 108 and this is 60 degrees. So the whole angle is 168 degrees plus 6, and 6 will give 180 degrees. So that's why angle AEX is 180 degrees. Okay, I want someone to come and do question 6 on the board. Chutali, good? Number 7. George. All right, number 6 first. B. Y plus 1. For seconds. Okay, well done, Chudali. What you could have done also, if this is an exterior angle, remember I said in the previous lesson that the sum of the exterior angles is always 360 degrees. You can also divide 360 by one exterior angle. It will give you the number of sides, which is 24. Okay, she's used the interior angle to find the number of sides. Clear? Okay, number 7, George. Yeah. Against you. Make them longer. Produce means you make them longer, extend them. So you extend AB to that side and extend DC, and they will meet at right angles. Although because of the way you drew the pentagon, but so long as you know that that's a right angle, it's okay. If you draw it properly, you will end up with a right angle. It's not a regular one. It's an irregular. If you draw it like that, you will get it's a right angle. On ATN, let n be the number of sides. Okay. 5 plus 2, which is 7. Where did he get the formula from? Let n be the number of sides. 180n equals 180 plus 144n, subtract 36n. George, why did you add 2? If you said that n is the number of sides. Give George the mic. Where is the mic? Or should n be the number of triangles? Because 180 times the number of triangles. If n is the number of triangles, then yeah, the number of sides is 7. Because to get the number of triangles, you subtract 2 from the number of sides. Because it's just, I'm just looking at this and I'm thinking about it, because if you multiply 180 by n, it's really the number of triangles, because that will give you the sum of the angles in a polygon. Because sum of the angles in a triangle is equal to 180. So can we change it to let n be the number of triangles? And I'll show you an alternative to if n is the number of sides. Okay, if n is the number of sides, it says a polygon has n sides, 2 of its angles are right angles, and each of the remaining angles is 144. Okay, if 2 of the angles is right angle, maybe that's this value comes from there. 2 of them are right angles, that means 2 times 90 will be 180. Okay, if I can just okay, remember also another thing. If a polygon has n sides, it also has n angles. Like if a A polygon has 3 sides, which is a triangle. A triangle has also 3 angles. A quadrilateral has 4 sides. It also has 4 angles, and so on. Okay, if this is a polygon that has n sides, if it has n sides, it also has n number of angles. Okay, 2 of them are 90 degrees, so the sum of those 2 is 180. And it says the remaining, how many angles? The remaining angles each are 144 degrees. So if this polygon has n sides and n angles, then if 2 are already 180 degrees, then the number of angles left is n minus 2. And then you multiply that by 140 because each of them are 144 degrees. Then this will be equal to 360. Okay, I used exterior angles. Can I just explain this again? Because some of you are not listening. You are writing. You're supposed to be listening first. If an interior angle is 90, the exterior angle is also 90 degrees. Okay, so this is where this 180 comes from. 2 right angles will give you this. If, 144 is not correct. If one interior angle is 144 degrees, then one exterior angle is 36 degrees, because 144 plus 36 will give you 180 degrees. So using the sum of the exterior angles will be equal to 360 degrees. If you use the sum of the interior angles, you will get 144 times n minus 2 plus these 2 will still be 180. Okay, this is the sum of the interior angles. I do not know the number of sides, so it will be equal to 180 times n minus 2. Remember, this is the sum of the interior angles of any polygon. You with me? So this is using exterior angles, this is using interior angles. You will get the same answer. Okay, if I do this, I get 36n minus 72 plus 180 equals 360. I subtract 180 from 360, I get 180, then I add 72 to 180, I get 252. So 36n is equal to 252 and n is equal to 7. Okay, you will get the same answer if you use this, because this one is based on the sum of the interior angles. Is that clear? Okay. Number 8. Anyone willing to do number 8? Nobody is willing to do number 8. Why? Okay, I'll explain number 8 then if nobody has done it correctly. In a pentagon ABCDE, angle A is 120 degrees, angle B is 138, and angle D and E are equal. The sides AB and DC, when produced, meet at right angles. That means when a side is produced, it is extended. It is made longer. Okay, you have to calculate angle BCD and angle E. If I can just draw the 1, 2, 3, 4, 5. Okay, the pentagon is not a regular pentagon. So some angles are bigger than others. So if I can make this A, B, C, D, and E. DC and AB are produced to meet at right angles. All right, angle A is 120 degrees. You should draw it a little bit bigger than this one. Angle B is 138 degrees. And angle D and E are equal. Okay, if this is 138 degrees, then this angle here, because this is 90 degrees, sorry, this is a straight line, 138 from 180 will give us what? 42. So this angle is 42 degrees. This one is now 48 degrees because 48 plus 42 will give 90 degrees. If this is 48, then this angle is 48 from 180, which is 132 degrees. So, and that's angle BCD. Okay, so angle BCD is now 132 degrees. You're then asked to find angle E. You just add, since angle E and angle D are equal, if I can call them X, 2X plus 132 plus 138 plus 120, those are the angles of a pentagon. That's equal to 540 degrees. And I think 2x will be equal to 150 if you add this and then subtract from 540 and x is equal to 75. Can you please check? Therefore, x is 75 degrees and this is also angle E. So angle E is 75 degrees. Okay, is there anyone willing to do question 9? Siegfried. Come and do question 9. Siegfried, do you want to do question 9? Kiapin? Come and do question 9. Where's the chalk? Use white chalk. You can clean the bottom part as well. Which one is that? Cha. What's the formula that they use? smart. He actually worked out that the lines BC and AD are parallel. I never thought of it that way. APE is 108 and BAD is BAD. BAD 72 degrees. See, he's really smart. He's going to work out the placement. Clear? Okay, angle APE is 108 degrees. Angle what? BAD is 72 degrees, which is alternate to this one. Okay, if you didn't work out that these two lines are parallel, there's also, you can actually do the question just by knowing that the inside angles are 108 degrees, because in a regular polygon, we know that all the lengths are equal. Okay, you were asked to find angle BAD and angle APE. Okay, if these two are equal, then this triangle here is an isosceles triangle. If this is 108 degrees, then this is, okay, if this is 108 degrees, what's the value of this angle here? This one and this one will be 36 degrees. Okay, and 36 from 108, because this angle is 108. 36 from 108, you will get 72 degrees. That's how you can work out that this is 72 degrees. And then if this is 36, you will work out that this is 36 as well. That means this is 108 degrees. But Kiapin, I think that was really smart. All right, number 10. Anyone for number 10? No one. Calculate the exterior angle of a regular polygon in which the interior angle is 4 times the exterior angle. It's just like the question that Chutaili did. But this one, the exterior angle is, the interior angle is 4 times the exterior one. Which means, if this are we listening? If this is the point where the lines of a regular polygon meet. This, let's say this one is the inside, the other way around. If this one is the outside, the exterior angle, the inside one will be 4x. That's what the question is saying. So you're supposed to just say x plus 4x is equal to 180 degrees. I know that x plus 4x is 5x. Okay? 5x is equal to 180 degrees, and x is equal to, what's 180 divided by 5? 36. The question is asking us for the number of sides the polygon has. X represents what? The exterior angle. Okay, this is the exterior angle and the interior angle. Now, how can I find the number of sides? Quickly. Kila.
$360 divided by 36.
Good. 360 divided by 36, the answer is 10.
10.
Right, number 11. Each exterior angle of a regular polygon of n sides exceeds by 6 degrees each exterior angle of a regular polygon of 2n sides. The question is talking about, Daniel, are you listening? The question is talking about two different polygons. One has n sides and the other has Okay, two polygons. One has n sides, another has two n sides. It says the exterior angle of this polygon is greater by 6 degrees than the exterior angle of this polygon. Okay, remember that if there are n sides, there are also n angles. Okay, and also the sum of the exterior angles is always 360 degrees. So if I wanted to find one exterior angle, given that this polygon has n sides, how would I do it? Or what would I do? Solomon? Mike is behind me. I want to find the size of one exterior angle of a polygon that has n sides. Yes.
You divide 360 by n sides.
Okay, 360 by n. This is one exterior angle. Similarly, if I wanted to find one exterior angle of a polygon that had two n sides, I would also divide 360 by 2n. Okay, if these two represented two exterior angles, this one is the exterior angle for this, and this is the exterior angle for this. Which one is bigger, according to the question? Which one's bigger, 360 on n or 360 on 2n? 360 on n. So I have to subtract 6 degrees from here, and it will be the same as the second one. That's all you had to do when you solve for n. Or otherwise, add 6 here, and it will be equal to the one that's bigger. So if I multiply by the lowest common multiple of n and 2n, which is 2n, I will get 360 times 2, which is 720, minus 2n times 6 is 12n, equals 360. If I subtract 360 on both sides, I get 360 on the left and 12n on the right. And 360 divided by 12 is 30. Is that the correct answer? Okay, so the value for n is 30, which means one polygon has 30 sides, the other has 60 sides. I wonder how you can draw that. All right, next question. Calculate the number of sides of a regular polygon in which the exterior angle is 1/5 of the interior one. This is very similar to question 10, and is also very similar to question 6. Okay, the regular polygon has an exterior angle which is 1/5 of the interior one. So if this is the interior angle and this is the exterior one. Okay, the exterior one is 1/5 of the interior. So if this is x, this one is going to be 1/5 of x. So you just add x plus 1/5 of x equals 180 degrees. Multiply through by 5, I will get 6x on this side. 180 times 5 is 900, and 900 divided by 6 is equal to 150 degrees. It says you have to find the number of sides. Divide 360 by 150. What's 150? No. 150 is the interior angle. The exterior angle is 1/5 of 150, which is 30. So this is 30. This is 150. You can divide 360 by 30 and you get 12. So the answer, 12 sides. Okay, that's 360 on 30, 12. Okay, I noticed one thing. Many of you didn't do the homework. If I had to name you, I would. I've been teaching a long time. I know I can tell who doesn't do the work. Okay, and the next time it happens, you are not going to be in class. Okay, your homework for the next lesson, you are going to come up with the definitions of the parts of a circle: diameter, radius, arc, chord, segment, sector, and a tangent to a circle. And I would like you to define them mathematically, not using mathematical words. And then we'll look at the circle next lesson. The keyword to the pilot teacher is circles, although we didn't do circles. Good afternoon, class. Good afternoon, Mrs. Thank you.